In this video, we are going to discuss how to find the pH value for a weak acid or weak alkali.
This video contains complicated and troublesome mathematical steps.
So far, we have learned to find the pH value of strong acid, which is an acid that is fully ionized when dissolved in water. And from the concentration of acid and basicity, we can find the concentration of hydrogen ion and finally get this pH value. This method works well so far. But what about the weak acid, which is partially ionized when dissolved in water? How can we find the pH value from the concentration of acid? Here, we introduce a new term called acid dissociation constant, Ka. Use this acid as an example. The acid Ha will undergo ionization to form hydrogen ion and an anion. The value of Ka is defined as the product ion's molarity over reactant's molarity. For ethanoic acid as an example, the value of Ka at 25 degrees Celsius is 1.74 times 10 to the power minus 5. Here is the equation for its ionization. At starting, we input the acid with molarity 1m. Of course, at starting, there is no ionization, so there is no product. Finally, after the ionization, we assume that there is Xm hydrogen ion formed. From the definition of Ka, we get this relationship and equals to our Ka value. Now here, we need to do some approximation to simplify our calculation. Because the value of X is much smaller than 1, so the denominator, we can assume the X will be cancelled out. By solving the equation, we get the value of X. And here shows, don't forget, the X represents the molarity of hydrogen ion. Now, we can get the pH value of 1m ethanoic acid, which is 2.37. With further calculations, we can find the hydrogen ion's molarity in different concentration of ethanoic acid. Again, this value valid only at 25 degrees Celsius. And their pH value? It makes sense because with less concentrated acid, the pH value should be increased. But what we concern more is the percentage of dissociation. For example, in 1m ethanoic acid, only 0.4% of the molecule undergo dissociation or ionization. With the concentration dropped to 0.001 m, the percentage of dissociation increased to about 13%. Now, we understand how to calculate the pH value for a weak acid. So, with the similar idea, we can introduce base dissociation constant, Kb, for alkali. And here is a typical example for the equation, how a base is dissociated, and the Kb is divided with similar idea. We'll take ammonia as an example. The value of Kb is 1.8 times 10 to the power minus 5, similar to that of the Ka in ethanoic acid. With the equation and starting and final molarity of each ion. So you can see, I try to ignore the concentration of water because in this case, water have two roles. It can be reactant or can be a solvent, so that we will ignore its concentration in the expression of Kb. With similar idea and approximations, we can find the value of X. Well, this time, this represents the concentration of hydroxide ion. But don't worry, we have pOH value, right? The pOH is 2.37 and the pH value is 11.63. Again, this is the molarity and the concentration of hydroxide for ammonia solution at 25 degrees Celsius only. Because with different temperature, the value of Kb or Ka will change, and their pH value and their percentage of dissociation. Again, with less concentrated solution, the percentage of dissociation will be higher. And now, we understand how to get the pH value for weak acid and weak base.